All right, it's now time to focus on power because we have spent quite a long time talking about type 1 errors and how we want to minimize them most of the time at all costs. But we haven't talked about power. That's the 1 minus beta area that falls under HA. That is the probability of correctly detecting a treatment effect. So we want to spend some time figuring out how can we increase the likelihood that we are in that area. So before we do that, let's see if we can identify, we have 4 areas under the curve. Let's see if we can identify those areas from the most preferred place that we want to be all the way down to the least preferred. And hopefully you can give me the area that we absolutely want to be in based on what we've just said. Don't we want to correctly detect a treatment effect? Wouldn't that be the prime real estate? So the first area, if we could choose, all right, we would want to be 1 minus beta. That's, again, where we've correctly identified a treatment effect. Now, we have 3 choices left. What would be the next preferred? Now, this might come as a surprise, and maybe some people would disagree. But really, our next preferred area is 1 minus alpha. Now, think, what is 1 minus alpha? That's the area, if you happen to be in it, where you have correctly retained HO. So you've correctly retained HO means you've correctly identified sampling error. And you might think, well, why is that great? Why is that second in our list here of most preferred places to be? Well, at least you're doing something correct, right? Don't you want correct decisions to take precedence over errors? So this would be correctly identifying a treatment effect. This would be a sad day. It's correctly identifying sampling error, but at least you were correct about it. The next one would be the probability of making a type 2 error. So this is where you think you have nothing, but in reality, you just missed it. And the reason why this isn't horrible, type 2 errors, nobody likes to have them, but the thing is that researchers, they never give up. They will tweak their experiment, they'll rerun it, they'll try and make improvements, and hopefully if there is a treatment effect there and we just missed it the first time, maybe the second or third time we'll actually detect it. Okay, so this is the probability of a type 2 error, and the most dreaded place to be in is alpha. That's the area representing the probability of making a type 1 error. And that's just because we don't want to say that something is significant and publish it, and later on we find out that there really isn't anything there. Okay, but do remember that last lecture I say don't just look at the effect on the discipline. You also have to look at the effect of a type 1 and a type 2 error for your particular study. So this arrangement is based on just in general, not looking at a specific study. This would be the order. Now let's focus on power. All right. Remember, power, if you're in that area, you have correctly rejected HO, and that means you've correctly detected that treatment effect, which is every researcher's dream. We always want to be in here. If we could choose, this is the spot we want to be. Now, remember that 1 minus beta is the probability of correctly rejecting HO. All right. Power means you have rejected HO correctly. All right. If your test has a lot of power, it means, you've correctly rejected HO. If we could know that, right? In theory, we're working with samples, so we don't know, right? That's why everything is based on probabilities. We're working with samples, not the entire population. But if we were to know that we're in that area, we would say, we would say our test had a lot of power. All right, so all of these areas, These are all probabilities. All right, make sure you understand that. If I give you a test question and I say 1 minus beta is correctly rejecting HO, that would be false. 1 minus beta is the probability of correctly rejecting HO. All right, now, how can we maximize this probability? Because if we can maximize this probability, that means we're increasing power. And at the same time, how can we minimize the risk of making a type 1 and a type 2 error? Right? That makes sense. We want to do that.